G'day, I'm Matthew Shepherd, and I made the ScratchPack. So the ScratchPack is a modified backpack which uses a robotic arm to scratch and or massage your back for you. I'll get more into that later, but for now let's focus on the problem. Back pain. Now, back pain can come from a range of things, one of them being posture, which is ever so present in our technology-focused society. However, the one factor of back pain, which really annoys me personally, is within school bags. Just got my bag here, packed as it would be on an average school day. See how much it weighs? That's looking like 9.4 kgs. See, according to kidshealth.org, a school backpack should not be any more than about 10 to 15% of your body weight. Now, I'm a pretty scrawny guy, weighing in at just under 60 kgs. So that backpack, it's like a good chunk over 15% of my body weight. So every now and then, personally, I get a bit of back pain, and it'd be really nice to have something which I can use to just soothe my back a bit. And that's where the ScratchPack comes in. Just put it on, as simple as you would any backpack with a couple of straps. Plug in the 3 necessary USB cables into their appropriate slots on the power banks. This is where the accompanying app comes into play. Select the Bluetooth device using the button at the top, and then hit the reset position button at the bottom to get started, which will take the ScratchPack from being limp to being stiff in an average position. You can use the different buttons on the app to move the end of the scratcher up, down, left, right,
in and out.
You can also tilt the head up or tilt the head down. Once you've got it in position, you can use any of the 3 toggleable modes. This includes twist, vertical scratch, and horizontal scratch, or any combination of the 3. Note that when the head of the arm is moved up or down, the head is moved directly towards or away from the base. Meanwhile, the wrist is kept at the same angle relative to the user's back. There are also limits on any movement using the shoulder or elbow joints. Without these limits, the components of the arm will collide into each other or put themselves in a position which is hard for the motors to sustain.
On the left strap is an Arduino controller. Above that you'll find a breadboard for more complex circuits, and on this is the Bluetooth module. Following the wiring upwards, you'll find the 4 servo motors which control the angles. The first one is inside the base, the second is on the shoulder joint, the third is on the elbow, and the 4th is on the wrist. There is a stepper motor inside the head of the arm to control the spinning of the 2-pronged spike plate. To create all of the custom parts of the ScratchPack, I learned 3D modeling in Fusion 360. Using this, I 3D modeled the head of the arm, the stalks of the arm, and the base of the arm. For the Arduino case, I didn't model this entirely from scratch, but I did take a model from the website thingiverse.com and modified this to fit my third-party Arduino controller. So I then 3D printed all of my parts. Once I had constructed the ScratchPack, I started working on coding, both on the Arduino and on my app, which I designed in MIT App Inventor. The ScratchPack is more automated than these massagery thingies. It's also more portable than a personal massage chair. And obviously it's easier to use than driving and seeing an actual masseuse. This word. Now the biggest advantage the ScratchPack has over these other products is how automated it is. Just set this bad boy going and you're free to go, I don't know, cook some dinner, make a sandwich, do your homework, I don't know, even try some juggling. Now this project definitely did have its challenges. I experienced a lot of setbacks. One of these was the problem that on its own, especially when limp, the ScratchPack can't hold up its own weight. To solve this, I redesigned and reprinted some of the parts with hooks for rubber bands. These rubber bands hold together the different components and therefore decrease the load that the servos have to lift. And finally, I had a lot of problems with the power supply. Certain motors, especially the one at the wrist joint, would tend to just stop working, and after a lot of troubleshooting, I had no idea why. Eventually, I diagnosed this to be a power supply problem, as there wasn't enough current being supplied to the motors. By stripping another USB cable and attaching it to the same power bank and then to the rest of the electronics, I managed to reduce this problem greatly. The movements of the wrist joint are still a little bit jumpy in the same way, but the problem is very much improved and I'm satisfied with the overall result, although I'll still look into this problem and see if I can fix it.